Hello, everyone, and welcome to this webinar. I'm Ramesh Sos, SyncPark's product manager and radio specialist at Actility, and I'm happy to present you today SyncPark's network coverage tool, together with my colleagues Aurore Ivano and Alampia. Before starting, let me wish, on behalf of the whole Actility team, a very happy new year with all the best wishes for 2025 and beyond. Let's take a quick look at today's agenda. We will start with a quick overview about the SyncPark network coverage tool, and then we shall take you to a guided tour of the tool's user interface to demonstrate its main functions, especially the new features brought by the latest version 2.0. And then we will give you the necessary information to access the tool and start doing your own coverage simulations. And finally, we shall conclude the webinar with a Q&A session. The Q&A has been activated, and you can now ask your questions on the Q&A box at any time, and we will answer them at the end of the session. The recording and presentation slides will be sent to all participants after the webinar. Let's start with a quick introduction about the tool, since part of the audience may not be familiar yet with it. SyncPark Network Coverage Tool, or TNC, is an in-house RF coverage prediction tool used for RF planning of LoRaWAN networks. The tool allows predicting the LoRaWAN coverage of outdoor macro gateways located on high points, such as rooftops or towers. But the tool is not suitable for coverage prediction of indoor gateways because such predictions require specific propagation models that are not supported by the tool. The tool is seamlessly integrated with SyncPark SaaS platforms, including SyncPark Community, SyncPark Wireless, and SyncPark Enterprise. Users have single sign-on experience, and the provisioning data of their base stations and devices is seamlessly propagated to the SyncPark network coverage tool. So what is the tool used for? Actually, there are many use cases. You may use the tool to predict the RF coverage of your future greenfield deployment. Such predictions will help you determine how many gateways are needed to cover your area of interest and assess the most optimum site locations, which maximizes the RF coverage with the minimum site count. You may also use the tool to generate coverage heat maps for already deployed gateways, then identify potential RF coverage holes and determine where to add new gateways to densify your network and remove white spots. As an example, this could be used when you want to deploy additional IoT use cases that require deep indoor penetration, while your network has been originally designed for lighter indoor penetration, which we typically call indoor daylight. Whenever you plan to add new gateways, a new feature added in the latest version of the tool helps you automatically select the best gateway locations out of a list of candidate locations. This feature is called Smart Antenna Selection, whereby all what you need to do is to provide the tool with an input list of candidate sites, including the antenna height above ground in each candidate location. You should also set the target coverage percentage that you want to achieve within the geographic area that you need to cover. And then the tool shall run an iterative process to determine which gateways should be activated so as to fulfill your coverage requirements with the minimum number of gateways. Last but not least, another new feature allows you to inspect the RF coverage status of the LoRaWAN devices already deployed in the field, then compare the RF coverage predicted by the tool with the real device KPIs, such as the connection health state, the uplink average packet error rate, and average SNR. You may also use this feature to overlay the location of your future devices with the predicted RF coverage heat map to determine if any devices lie in an expected coverage hole. To run RF predictions as accurately as possible, the tool relies on various sets of inputs, starting from the device characteristics, like the maximum transmission power and antenna gain, the gateway characteristics, including the propagation environment of each gateway and its antenna height, the local regulations imposed by each country are also considered by the tool, such as the maximum allowed radiated power. And since a reliable link budget analysis is a prerequisite to any realistic radio planning simulation, the tool internally computes a bidirectional LoRaWAN link budget considering some default assumptions that users may customize if needed. A rich set of RF antenna patterns are embedded in the tool, together with topography maps and tune field-proven propagation models. With these inputs, the tool generates RF coverage prediction maps for various penetration levels, and leveraging the smart antenna selection feature, the tool also generates an optimum list of gateways required to meet your original coverage objectives out of a bigger list of candidate gateway locations. Since Actility gives tremendous attention to the accuracy of predicted output from the tool, extensive field tests were conducted by the radio team to validate the accuracy of our RF propagation models and tune them as needed. Based on over 370 measured links in different environments, ranging from dense urban to rural morphologies, the average delta between the field measurements and the predicted pulse loss is within 1 dB using the safe prediction model, as you can see from this table. An alternative propagation model is available in the tool. It's slightly optimistic for all environments except urban, but it remains reasonably close to field measurements. And now let's switch to the demonstration of the tool's user interface and its latest features. So here I'm logged in to my ThinkPack community account, but as I said, the tool is also usable whatever your subscription, either ThinkPack community or ThinkPack wireless or ThinkPack enterprise. So in this, you can see here that under my account, I've already provisioned 35 base stations. They are in initialization state. It means that they have not yet been deployed or connected in the field, but they are just provisioned under my account. So this could be typically the case of a future deployment for which I have already provisioned my gateways and want to check their coverage. So if I want to access the network coverage tool, from the left panel, I go under Network Tools and I go to Network Coverage. And now I am already logged into the network coverage tool. And accordingly, when I land, I directly go to the dashboard. Under the dashboard, if I have already have some simulations run previously under my account, so the first widget here will provide me with a synthetic view about the map of my last coverage that I can also check in details by clicking on it. And also I have a widget that provides me with information about the status of my different simulations already done. So here, for example, I have 6 simulations run and they are all in success state. And also the third widget is about the base stations that are already registered under my ThinkPack account. In my case, it's ThinkPack community, and that are directly retrieved by the tool without having me to retrieve them or to redefine or redeclare them in the network coverage tool. So here in my case, as I shown you, so we had 35 base stations under my account, and these 35 base stations are directly retrieved in the network coverage tool from my existing ThinkPack community account. Under the different base stations, actually all of them are marked as green, meaning that they are outdoor base stations, which are eligible for my simulation. They are not indoor base stations, and they have valid coordinates. If we have some base stations which are either indoor or outdoor without valid coordinates, so they are marked as such, so that for those who are missing coordinates, I have to add their coordinates before doing the simulation, or for others which are indoor, which are not eligible, I cannot include them into my simulation. If I want to go one step further to show you the different base stations which are retrieved by the tool from my account, so they are under base stations here from the left panel, and here you can see the list of all the base stations. They are 35 all in all, and for each of these base stations, if I open it here, you can see that it's an outdoor base station in initialization state. I have not set any of those flags on my own in the network coverage tool. This has been automatically retrieved from my account. And the tool has also automatically retrieved the necessary information about each base station, like its location, longitude, latitude, and its antenna height above ground, as well as the environment parameters, like the propagation environment in which the gateway will serve, so dense urban, suburban, or rural, and the installation mode, the only mode that is really valid in compliance with the network coverage tool is the installation mode, where gateways are installed outdoor above building rooftops, so at high points, as mentioned in the past. And the RF information regarding my antennas, like the antenna gain and cable loss, are also inherited from my settings in my ThinkPack account. So all this is read-only, because information, if it needs to be populated or changed at any time, it needs to be done directly under my ThinkPack account. So if I go here, for example, to the list of my base stations, and if I go to the first base station that I was just showing in the network coverage tool, so you can see that in this base station, if I want to set its location, that's here that I need to set its location, either manual or through GPS if the gateway is really connected to the network. But it's not connected in my case, so I have to set it manually. And this is how the location will be inherited in the network coverage tool. And other information regarding the base station, like the antenna gain and cable loss, are under the antenna object associated with the base station. Here in my case, there is one antenna, it's omnidirectional antenna, and it has a gain of 6 dBi and cable loss of 0.5 dB. And the antenna height above ground is set to 35 meters. I can change it whenever I want directly here, and it will be automatically taken into account in the network coverage tool. And the environment parameters, like the propagation environment and the installation mode, are directly set here and retrieved by the network coverage tool as seen before. So if you want to do any changes, we recommend you to do the changes under your account in ThinkPack, and then they will be automatically retrieved from your network coverage tool, rather than having to set that manually in the CSV file that you would need to import, as we will see in the next part of the simulation of the demonstration. So going back here to the list of base stations, you also have the visibility about which gateways have valid coordinates, for which the coordinate is marked in green, and which gateways have compatibility with the scope of the network coverage tool, means that they are outdoor gateways installed above surrounding building rooftops. And then I can quickly show you the different antenna patterns that are already inherited in the tool. So we have many antennas. They are not sample templates. They are real antennas that are really deployed in the field. They are commercial antennas from multiple vendors, and they have different antenna gains. The propagation model and the radiation diagram of each of these antenna has been already incorporated in the tool for both horizontal and vertical planes. And accordingly, all what you need is to select the antenna that matches your deployment. And if for any reason the antenna you want to choose is not within the list here, don't hesitate to contact Actility, and we will have the necessary information available so that this antenna can be added to the list. And then before showing you how to do a new simulation, if I go to the simulations tab here, I will see the list of the different simulations that has already been done under my account and their status. And a good thing to look at before launching new simulation is to check under your user preferences here if you have properly set the default settings of your account, so that it becomes easier for you to run simulations. With these default settings, you can choose what is the country in which you would like to run your simulations, so that it's automatically set for every new simulation without having you to set it separately for every simulation. And the same thing also regarding the base station settings, like what is your preferred antenna model that will be taken by default in all the simulations. And of course, you can override this for a specific simulation if needed, but at least having this as part of your user preferences will allow you to easily run new simulations without having to enter that every time. The same thing related to the typical cable losses that you would like to have in your for your base station deployment, and also what is the maximum hardware radiated power that is supported by your base station. This is also something that could be interesting to set once and for all under your user preferences without having to set that separately every time. Under the device settings, also it's important to set parameters related to your device characteristics that are realistic and that are compliant with the devices that you intend to deploy in the field. Because if you set parameters that are too optimistic compared to what you expect in the field, it means that your prediction results will be more optimistic than your real coverage in the field. So it's important to make sure that you are aware of the different device models that you plan to deploy. And for those device models, to check their data sheets to make sure that you know their conducted transmission power and their antenna gain. Sometimes we have devices with negative antenna gain. So it's important to make sure that those settings are properly set, and not only set for the best case if you have many devices in the field, but to be set for the worst case if you have many models that have different characteristics. And the height above ground, we typically set it to 0.5 meters because this simulates kind of worst case where device is really very close to the ground floor. Whatever its final location, whether is it indoor or outdoor, we prefer always keeping this value of 0.5 meters to simulate a kind of worst case. And once you are done with that, if you want to change anything, you can just save back your configuration. And then, now that you have set your default settings, you can go to the next step if you want to run new simulations. So you click here, Add Simulation. And then you can give for your simulation, you can give it a name. I will set, for example, Demo Outdoor. And I can add in additional information, like, for example, no optimization. Because in my case, I will not activate the Smart Antenna Selection feature because I want to show you the typical case when I want to do a simulation for all the gateways that I have, that I will import without having to ask the tool to do any optimization. And then in a later iteration, I will show you how to use the optimization. I will keep the safe prediction type because I want to run simulations with prediction models that provides the most realistic results compared to the field tests. And then I will move next. Here, you see that my forms are already pre-filled with the data that I already have set under my user preferences. But again, I can change this if for any reason the values that I have set under my user preferences are not the right ones for a given simulation, or maybe because I want to do different cases and I want to check the impact of changing, for example, the device antenna gain on the overall coverage. In my exercise here, I will make a simulation for outdoor gateways, but then I will show you other cases. The tool already supports 4 penetration levels, so outdoor, and then 3 different indoor penetration levels. So the indoor daylights, or what we call indoor first wall, is where you are close to the window on your building. And then deep indoor, it's when you are really in the center of the building after several walls. And the basement is where you are most typically underground. Like, for example, you have a garage or a parking that you want to cover, or you want to have devices that are located buried in the ground, like, for example, for meeting applications. In my case, I will just use the outdoor, and then I will keep the 0.5 meter for the device height above ground. Regarding the regulatory settings, so the main thing I want to add to set here is the country. So if I set the country, all the other information related to the ISM band and the radiated power for both uplink and downlink is automatically inherited by the tool from the country of operation. So here for France, this is filled according to the regulations in Europe. If I want to change that, for example, to be in the United States, so you'll see that it automatically updates to US 915 with the respective regulatory limits that are imposed by FCC. For my case, I will just go back to France because that's where I will do my simulation. And then I click Next. And then I go to the advanced settings. Under the advanced settings, again, these are pre-filled, but feel free to change them if you have enough information to change the default settings. Like, for example, for the noise rise for uplink and downlink, this is typically an engineering margin that we add to the link budget on top of your typical sensitivity in order to account for the interference margin of the background medium, since we are using an ISM unlicensed spectrum. So there are typically some kind of interference and collisions that are available in the spectrum. And accordingly, we need to account for this additional interference margin. If you don't know which value to set, you can keep the default settings because this is what we typically see from many field deployments. But it's always recommended, if you have the possibility to do so, to run spectrum analysis with RF noise scans if you have access to some gateways at high points, whereby you can do some advanced analysis and check what is the effective and real level of background noise that you have in your spectrum. And for that, you can easily rely on SIMPAC's spectrum analysis tool to launch the noise scan and to analyze it and get the values that you can directly set here as part of the advanced settings of your simulation. Another part of the advanced settings that you can also add here is about the spreading factor and number of transmissions that you could set for both uplink and downlink. So for uplink, it's important to make sure that according to your local regulations, but also according to the capabilities of the devices you intend to deploy, that you provide a combination that allows you to stretch as maximum as possible your coverage. So for example, if you use European deployments and your devices can go up to SF12, which is the lowest data rate or the highest spreading factor, and they are allowed to use repetitions, so it's good to consider this combination to maximize your uplink budget. It doesn't mean that all your devices will have to use this combination in the field. It will be just the case of devices which are at the cell age requiring higher link budget to still remain connected with the network. But if you deploy, for example, some devices which cannot ensure this combination, like, for example, any device that, for sake of power budget, does not allow repetitions over SF12, so in this case, you are required to really set what is supported by the device, in which case, for example, you can set only one transmission instead of 3 when you deploy devices that cannot do repetitions on SF12. In my case, I will just run with 3 because in the case of this demonstration, I want to show the coverage for typical devices that can do repetitions. And for downlink link budget, we rely on the RX2 link budget, for which we can set, for sake of enhanced link budget, we can set the spreading factor to SF12, which is the maximum authorized. Regarding the digital elevation model and the diffraction settings, they are already pre-filled to the recommended settings according to your network of operation. So in most cases, you do not need to change the default settings recommended by the tool for your country of operation. And then we come to the state where you would like to import a CSV file with all the candidate gateways that you would like to use for your simulation. So to do that, either you want to rely on the base stations which are already under your account, under your SIMPAC account. Remember the 35 base stations that I showed you under my account, or you want to start from a blank page and you want to import the base stations you want by using a CSV file, for which you can simply download the sample file to know the structure of the CSV that you want and should import. But in my case, I will just do the simulation for the 35 base stations under my account. So I will export the list, and I will show you that the file will be already pre-filled in my case. So this is the structure of the CSV file that I open under Excel. You can see here that we have the LRR ID for each base station. So if you don't have the LRR ID, it's just a unique ID that you need to set for every base station or every gateway. And then the coordinates of your gateways, so the latitude and longitude. And you have also the height above ground of each base station. And then you have the propagation environment, so either dense urban, urban, suburban, or rural. In my case, the gateways I have chosen for the demonstration are all located in rural area in France. So I've set it to rural. And then the antenna pattern, which is actually inherited from the setting you have put under your user preferences, but you can change that for specific gateways if you do not have the same antenna for all your gateways. And finally, the cable loss. So you can see here, because I have properly filled the information, the required information for all my base stations under my SIMPAC account, so all this information is automatically pre-filled. I don't have to change anything if I'm satisfied with what I have already set. But of course, if I want to change something, I can be free to change that directly in the CSV file. And since the file should be well formatted without any missing data, all this data is mandatory. So the tool will inspect the CSV file and tell you if there is any error in the imported file. So just to simulate to you a case where I have an error, I will just omit this value and I will save my file. And then I will show you that if I import it as is, the tool will tell me that it cannot go through. So I go next. I will import the CSV file that I have just done. And the tool will tell me, no, there is an error. I tried to import 35 entries, one for each base station, but the last one has a missing antenna pattern. So in this case, I need to go back here and change my CSV file, in which case this file is the right one that has the right antenna pattern. I will set it here. And in this case, everything goes fine. And I don't have any more errors. So now I can proceed to the next step. In which case here, the last step, it tells me that I'm ready to launch my simulation. And then it asks me what I need to do. Do I want to run the simulation for all the 35 gateways that are shown here on the map with their location? Or do I want the tool to set the smart antenna selection feature in order to optimize the base stations that I need to cover a certain area? So in this first iteration of the demonstration, I do not want to activate this because I want to show you the outcome when I do the simulation for all the gateways with the optimization deactivated. So now I say, I'm ready, I can start my simulation. An important thing to note is that if I don't have enough credit, the simulation cannot start. So here I have two kinds of credit. I have free credit that is typically set to 5 base stations every 90 days, every quarter. And then if that's not enough for my use, I can buy extra credit from the SyncPark market, as we will show you just after the demonstration. So if I don't have enough credit, I cannot launch my simulation. That tool will generate an error. And in my case, I have enough credit, so everything can go well. One base station needed in the simulation, so one base station imported in the CSV file, counts for 1 credit in the simulation. So for sake of time, depending on the load on the server, depending on the number of gateways that I add to my simulation, and also the area of interest, the size of the area of interest, the simulation can take more or less time. You don't need to wait in front of the simulation, although you will see that there is an interactive progress bar showing you the progress of the simulation, but you do not need to wait in front of it. You can just wait to receive an email once the simulation is completed, an email like this one, sent to you to tell you that the simulation has been completed, and it will provide you with the link to access the simulation details, the simulation results, and also it will provide you in attachment a KMZ file with the simulation output, the coverage map, that you can directly open on Google Earth if you want. So just for sake of time, I will not wait for the result of this simulation. I will show you the result from another simulation, exactly the same ones that I have done before the demonstration. So here you can see the demo outdoor, no optimization for 35 base stations. That's what I did. And the optimization has been deactivated. If you want to check the details or remember the details of your simulation, what settings you have set, so you can unfold here, and here you get the details about what you have set under your simulation, and you can also retrieve the CSV file of the base stations that you imported for the simulation. In my case, I will just go into the simulation details, and here I can see the coverage map of my gateways. They are 35 gateways, and here, if you remember, that was an outdoor simulation. So while I have the settings up to the outdoor level, the tool also tells me what is the proportion of coverage that can be covered for basement, for deep indoor, for indoor daylight, in addition to the basic outdoor level that I wanted to add as the constraint or the design rule for my simulation. So here you see the coverage for the 35 gateways, and you can click on any gateway to get more information about its details, and also the result of the link budget. Like, for example, what is the limiting link? Is it limited by downlink or by uplink? Because as we said before, link budget analysis is a preliminary stage for the radio coverage exercise. So you can get some insight about the design, about the outcome of your link budget analysis by checking the feedback on each gateway. And then if I go this way, let's assume that I want to export the result of my simulation. So I can go here, I click download, and I can export the result of the whole simulation, not only the outcome, but also it includes all the different inputs that I have for my simulation. So after unzipping my package, it becomes something like that. You have the CSV file, which includes the base stations that you have imported. You have a JSON file that provides you with a reminder of all the settings related to your simulation. And then you have the simulation output or the coverage map under 3 different formats. A KMZ format, which is compatible with Google Earth, but on top of it, you have also the simulation outcome in PNG and TIFF formats. It's recommended to always store the data separately outside the server, because the simulation results are available only for 90 days before being erased from the server. So it's always good to back up your data if you want to keep them for longer. So that's the case for my original simulation, and here are the details. And let's assume that in my case here, I want to run another iteration of this simulation by saying, okay, that's good. Now I know the outcome of the coverage with the whole 35 gateways, but I want to know if I really need all the 35 gateways, or I can simply optimize the number of gateways while still providing coverage for outdoor use cases. So I will duplicate my simulation. I will click yes to duplicate, and then it will already pre-fill all the required information because it's a clone of the previous simulation. And here I will do demo outdoor, and I will run with optimization. And here I will activate the optimization scope in order to let the tool tell me how many gateways are needed to fulfill the coverage requirement with the least site count. So here I will add smart antenna selection, for example, as additional information for me to remember later. And then simulation settings, I will not change anything here. I will not change the advanced settings. And then under preparing the base station list, I have the possibility to retrieve my CSV file. So I can retrieve the file so that I can re-import it as is in the next stage, or I can add additional candidate locations. For example, if in addition to the 35 base stations, I can add new candidate high point locations to help the tool optimize to the maximum the site count based on the different candidate site locations that I might have in my deployment. In my case, I will just move to the next step. And under the CSV import, I will still import the same file with the same 35 base stations. And here, when I click next, instead of just launching directly the simulation, I will tell the tool, I want you to optimize the number of sites by activating the smart antenna selection. In this case, the tool will tell me I need to set what is the coverage percentage, the coverage probability that I want to have within an area of interest, and I want to set this area. So first, I will set the area by drawing this polygon. Let's, for example, do it something like that. From here, I go, for example, there, and then I go down here, and then I go this way, for example, and then I go here, and then I close my polygon. So that could be, for this case, that could be the polygon of interest. This is the area that I want to cover. And I tell the tool, choose within those gateways, the 35 gateways, which gateways need to be selected and activated so that I can fulfill this area with 95% coverage. That's what it means. Of course, 95% could be 98, could be 90%. It all depends on your design requirements. And here I will click Start Simulation. And when I start my simulation, the tool will do the optimization in a way that provides me with the expected coverage to fulfill 95% and how many gateways have been activated. So let me run the simulation here, for example. So here I see my original simulation with the optimization deactivating that is still running, and then the other simulation that is still under initialization state. Again, for sake of time, I will just show you the outcome of this second simulation without waiting for the result. So this is a demo outdoor, but here with the smart antenna selection activated. So here you see that the optimization has been activated, and the tool has, out of the 35 gateways, it has activated only 14 gateways out of 35. And we have here a happy face saying that when the optimization has been activated, we have reached the coverage target, which was set to 95%. So if I go into the details here, you can see how it looks like. The tool here has activated the gateways which are in dark violet, and all the gateways that have been deactivated are the ones that are set here with almost gray or pale violet. And for this, you can see that not all the gateways have been selected. I want to cover the area of this polygon with 95% probability, and the tool has found unnecessary to activate all the gateways. So part of the gateways have been activated. So I have only activated 14 gateways out of 35. And if you want to get the optimization sentences, so you can see that I have requested 95%. The tool has effectively provided coverage with 95.21%, and this has been the result of activating only 14 gateways out of 35. The details about the gateways activated is provided here. So you can see that the tool has applied an iterative process by which it has started by activating the gateway that provides the highest ratio of individual coverage within the area of interest. And then it has progressively added additional gateways in order to progressively increase the aggregated coverage ratio from the original value from only one gateway up to having the target of at least 95%. And here you can see the incremental coverage brought by each additional gateway added to the list is just put here between brackets until the last one, which has been added just to fulfill the target. Before this gateway, we were still below 95%, and adding this gateway, it added only 0.54% of the overall coverage, but that was enough for us to reach the coverage level of 95% at least. And then you can still download the result of your simulation. In the download file, you will see here that unlike the previous file, you will have additional information in your download. So besides the CSV file that you used for the base station import, you have the JSON file. And in the JSON file, you will see also the information about the polygon that you have already set, so that you can know exactly what is the area of interest that you have defined for your simulation. And besides the different output formats, you also have the optimization results to tell you which gateways have been selected or activated, only 14 gateways, while the other ones have been deactivated because they have been seen as not necessary. And for all the gateways that have been activated, what is their individual coverage ratio, and what is the aggregate coverage ratio after adding each gateway to the list, and what is the incremental or the added value of adding each individual gateway to the overall coverage. Okay, so that was the second simulation. And what if I want to run a third simulation saying, okay, that's good. Now I have matched the coverage requirement for outdoor, but I want to add new use cases that would not require only outdoor coverage, but would require indoor coverage. So here I can still clone my simulation. Here I can go here and I do a clone. And in this case, instead, I will still activate the smart antenna selection, but instead of doing that for outdoor deployment, I will do that for indoor daylight use case. And then I will keep the other settings, advanced settings. Sorry, I will have to go back here because instead of outdoor, I will set indoor daylight. And then I go next. And then I will keep those settings. I can retrieve my CSV file, but I already have it. And here, I will do exactly the same thing by importing my CSV and by by activating the smart antenna selection. I would not do that just for sake of time, but the only change that I have done with this simulation compared to the previous one is that I would like the tool to optimize the number of sites that I want, not only to provide outdoor coverage, but to provide indoor daylight coverage. So without running this simulation, I will show you the result. And you will see here that under the demo indoor daylight, smart antenna selection, actually, the tool tried to fulfill the coverage requirement of 95%, but actually it didn't really succeed to provide indoor coverage with 95% for the whole area. So it has already activated 29 gateways out of 35, but that was not still enough, because to have 95% coverage, we had to add additional gateways to densify with additional gateways, while with only 29 gateways, we could not achieve the target of 95%, but only almost 80%, so 79.75%. So it means that we need to add additional gateways in order to fulfill the overall coverage. So we might ask, so why the tool didn't activate additional gateways since we have more than 29? But actually, the other gateways that the tool could not activate are actually outside of the coverage area of interest. So there is no point for the tool to activate them, because anyway, it would not improve the coverage within the polygon or the area of interest. So the only way to improve that and to support indoor daylight use cases, or deep indoor if you want to have other use cases, is to add additional gateways to fill the white spots provided here by the current simulation. And that's why in the optimization analysis, we don't have anymore a happy face. We have a face, in orange face, saying that the coverage requirement has not been really fully achieved. And then you can see, like all the other cases, the details of your simulation. Now, to move forward with the dataset part, the device dataset part of the demonstration, let me hand over to my colleague, Aurore Yverneau, who will continue with you this part of the demonstration.
Hello everyone, I'm Aurore Yverneau. I'm a ThinkPark Enterprise, so TP project manager and also radio expert at Actility. And I will show you the devices dataset. So for the devices dataset here, you can actually export all your end devices provisioned on your TP or ThinkPark account. Only the devices with valid GPS location. So you can export them as KML files, so you can then import them in Google Earth. So you can export your end devices with several parameters, so either with noise or signal power, spreading factor, packet error rate, or health state. So I will choose this one. And then you can import them in Google Earth. You can also import your simulation results. So I will choose the indoor daylight that we previously done. For the end devices, you can remove the labels if you want for better view. So here we have all the gateways that are selected by the smart antenna selection with this color, and you also have their information, and you also have the gateways that are not selected with also their information. For the end devices, you have everything here. These devices does not communicate with ThinkPark platform, so we don't have any value here, but of course it will be displayed if your device already has communicated. For the end devices, there are also several colors. Here we have only devices that are in initialization state, so they are only in orange, but if we have other devices, they will have different colors. The color displayed can be found in the documentation here. So you can find it on the online documentation in network coverage, interface overview, and then you have devices dataset, and you have all the values for the colors for the devices tag. So here for the results, you see that you have devices that are perfectly covered by the gateways. And then we have also some devices that are absolutely not covered. So for example, for this one, you will need to add a gateway near this device for it to be covered. If you want to save all of this into one Google Earth file, so your devices and your simulation results, you can do that by doing a right click on temporary places here, and then save place as, and then you can set any name you want, and then save. And you will have only one KMZ file to be opened with Google Earth to have all of this inside. Okay, so that's it for me. Back to Ramez now.
Thank you very much, Oro. So we hope that this demonstration has provided you insights about how the SyncPack network coverage tool can help you assess the RF coverage of your LoRaWAN network deployment. If it's not already the case, do you want to try it out now? So the tool is accessible for free through the SyncPack community platform. If you don't already have a SyncPack account, sign up for SyncPack community through this URL or by directly scanning this first QR code. With SyncPack community, you have a free credit to simulate the coverage of 5 base stations every quarter. And to go beyond this freemium credit, you can buy extra credit on SyncPack Market as shown here. And of course, using the tool is not restricted to SyncPack community users. If you already have a valid SyncPack Wireless or SyncPack Enterprise subscription, you can fully use the tool and buy credit as needed, either through the SyncPack Market or by directly contacting your Actility sales representative. The last QR code directs you to the online user guide. Check it out to access the detailed documentation of the tool. And now here we come to the end of our presentation, but the webinar isn't yet over. It's now time for questions and answers. So we have many questions. We will try to answer as many of them as we can for today. So I have already tried to post some answers online in the chat, but I will try to take a look at them one by one. So the first question, actually this question comes several times related to on-premise deployments. So the question is, does it mean that the tool is not available for on-premise instances? So Alan, can you probably answer this one?
Yes, sorry. Good morning or good afternoon, people. In fact, the tool is available currently on SyncPack on community platform, so on community TPE platform. It is also available for on SyncPack SaaS Europe for at least Actilities and operators that are hosted in Actility SaaS platform. There is no, and also it is also available for TPE in America and US and in Asia also for Australia. If I remember well, there is no. It currently is not available. It is not available for any OCP instances. So it's really running on SaaS platforms.
Yes. So, as you said, Alan, so if you are using an on-premise platform and you want to use the tool, today you can still use, for example, ThinkPack Community if you have enough credit and you want to use the tool by simply importing the list of your base stations that will not be directly retrieved from your account, since an OCP account is not yet integrated by API with the SaaS platform. So you can still use that if you want. And if you have a big deployment volume on your OCP platform and you would like really to install the tool on premise, or at least would like us to do the integration work between your platform and the SaaS platform over API, that could still be done. But you just need to contact Actility offline so that you can find the best way to serve you in this. Another question, so thank you, Alan. Another question, what kind of coverage is supported by the tool? Outdoor, indoor, deep indoor? Can we tune the corresponding level? Yes, actually, that was also one of the things that we have seen later in the demonstration. So several coverage types are supported. So it ranges from outdoor to indoor penetrations, going through indoor daylight, what we call indoor first wall, and then deep indoor and even basement for devices that may be located underground, for example. And that's completely tunable in the tool when you launch your simulation. Another question, can you support gateways from different manufacturers? So, Aurore, can you answer this one, please?
Yes, we actually support different types of gateways and also different types of LoRa antennas. You can find the list in the online documentation.
Thank you, Aurore. And then another question, it was still about on-premise deployment, so I think we have already discussed that. Another question, device characteristics. So assume this is the sensor signal level. Are a set of guidelines suggested for this given that the network isn't designed against a specific sensor, but designed to cater for the general sensor market? So designing coverage for all potential sensor types and signal strengths in the market. So I fully agree. And that's why when we speak about the device characteristics, as I mentioned during the demonstration, we should not consider the typical case, we should consider the worst case. And here we are not speaking about the sensor sensitivity, because I understand from your question is that you are afraid that we are looking into the specific sensitivity of each sensor. That's not the idea. The idea is that we need to make sure that if you have multiple sensors you would like to deploy, and each of them having different maximum allowed conducted power and the different antenna gain, so that we cater for the worst case scenario, not for the typical or the best case scenario. Otherwise, the design will not be fit for all your use cases. So that's why a good design has to cater for a worst case. So I hope that this answers your point. How are the free credits consumed? So actually, we always first consume the free credits before eventually consuming the paid credits, because free credits expire. So they expire every 90 days and they are refueled. So that's why we always, whenever you have a new simulation, we first consume as many free credits that we have to fulfill this simulation. And only if we don't have any more free credit, we go to consume the paid credits if you have already bought paid credits. Which propagation model is used? So as part of the initial presentation, the theoretical presentation in the slides at the beginning of the demonstration. So we use two propagation models. They are both empirical propagation models. They have been both tested against field measurements in the field. One of them is the Hata-Okumura propagation model, but this Hata-Okumura propagation model is not used as is. It has been widely tuned in terms of morphology correction factor in order to get the best results compared to what we have already seen and measured in the field. And another model that we use is a variation of the standard propagation model. This one is the optimistic model that we refer to in the tool, but this one has also been tuned with specific propagation, so clutter correction factors, still to match to a very good degrees, as you have seen in the table, the field measurements that we have done in the field. And there is a question about the geo data and in zero resolution. Alan, can you take this one, please?
Yes, of course. In fact, we use depending on the location where the simulation is done, we're using either a DTM dataset on continental Europe. Otherwise, if we are outside Europe, we are using the Japanese Space Agency, the JAXA dataset that were published for 2022 or 2023. The last updates were on 2022 or 22-23, I guess. And this is and then those files outside of Europe are not DTM but DSM, so digital surface model.
Thank you. And resolution of both topographies, if I'm not
yes,
it's 30 meters.
It's 30 meters, exactly. Sorry, I forgot the point. Exactly.
Thank you, Alan. Okay, next question. What is the maximum device support capacity? Sorry, there was one question before about GLAMOS field test device to be added in network survey. So it's not perfectly the focus for network survey, but I may answer this. It's something that we can add in our catalog. It's not yet the case, but indeed, I will talk to our colleagues from the SyncPark catalog team in order to add GLAMOS field test device together with its payload driver to our list of decoders and device profiles. What is the maximum device support capacity? So, properly speaking about the network coverage tool, there is no limit. So you can, if you are speaking about exporting the list of devices from your account to SyncPark community, so you can do that whatever the number of devices that you have under your account. But generally what will limit you in this kind of export is the maximum number of devices that you can already have under your account as per your license. So for example, in community, there are only 50 devices authorized with a freemium approach. How is the antenna pattern taken into account? Back to you, Alan, if you can also answer this.
The antenna pattern is taken, in fact, after all the link budgets have been computed. So it means that, in fact, when the simulator is predicting the strength of the signal in a geopoint, in a given geopoint. In fact, it computed with the mathematical model of propagation the losses. Then it takes in account also the pattern of the antenna, and it also takes in account, I will say, a part of a diffraction mathematical model in order to reflect diffraction impact from the environment. And this is the final results of adding or subtracting this measurement, this predicted measurement that gives a value of the signal strength, and that is then plotted or color, that is reflected, shown as a color on a map.
Exactly. So thank you, Alan. So indeed, as you have mentioned, since we take into account both the horizontal and vertical antenna patterns of each antenna, so based on the vertical pattern, we can see when we take into account the effect of diffraction on the topography, on the Earth's height, so we can define what is the position of the first obstacle that would finally declare or define what will be the incidence angle from the gateway to the first obstacle. Thank you. Are sectorized gateways also used in the network coverage tool? So as of today, we only support omnidirectional antennas, but if there is specific need to support sectorized gateways, there shouldn't be any showstopper at this stage, because that's something that can be easily added to the tool. Height above ground, does it mean the height above surface, DEM, or from the ground, DSM? So this is the height from the ground. So it's as if you are at the street level, at the ground level, and this is the height from the ground level towards the antenna. What is the loss difference between outdoor and basement in your calculation in dB? So actually it depends. For dense urban, for example, we have around 33 dB loss difference between outdoor and basement, whereas in rural, because the incidence angles could be different per morphology, so this value goes to 26 dB instead of 33 in dense urban. Does the antenna for LoRa 868 or 915 megahertz need to be UNB antenna? So I understand UNB as ultra narrowband antenna. So to my knowledge, no. Actually, we see already many antennas that do not need to have very narrow bandwidths. Many of them could even, of course, they should support the whole range, whether in 868, so 7 megahertz, or in 915. In US, for example, it covers a big range from 902 to 928. And even some antennas we see in the field, they are dual band. They support both 868 and 915. So I don't think that the antenna needs to really be ultra narrowband. Is a tool also suitable for simulation of an industrial outdoor manufacturing site? Yes, of course, that's possible. So I think I have also directly in the chat answered another question related to refinery. So if you have this kind of industrial use cases, outdoor industrial use cases, that's perfectly fine by the tool, as long as your antennas are located at relatively high points, so higher than the average height of the surrounding media. And for this, you can also use a suburban model if you want to associate your gateways to an environment. 90% coverage in which service class? Can I choose one? So I think I've already answered this part by chat. I'm not sure that I have got an answer to my last question. Sorry, I cannot see it. And otherwise, if you have already answered, Michael, so I can also contact you offline to understand what you mean exactly by service class. But anyway, as we have seen also from the demonstration itself, 95% is something that you can perfectly change according to your need. It actually means that when I want to do my coverage analysis and I want the tool to optimize that, am I happy to consider an SLA of 95%, 98%, 90%? It all depends on your design requirements.
Rames, maybe service class, Michael means by service class, class A, class B, or class C, maybe.
In this case, so it's completely independent. Actually, the LoRaWAN class of the device, class A, class B, class C, is something that is completely independent from our simulation analysis. So it can work the same way, whatever you're using, class A or class B or class C, as long as our simulations already consider a bidirectional link budget that works for both uplink and downlink. Can I tell the tool that I like to have redundancy so a failure of a gateway doesn't impact me? And there is another question just afterwards also speaking about overlapping and redundancy. So actually both questions can be answered together. That's a very good point. And actually that's something that we are actually looking at in one of the upcoming versions of the tool. We want to make sure that we have part of the output, we have the number of gateways that can cover each part of our coverage map. So not only to have the signal level or whether the pixel is covered or not, but also how many gateways or the number of gateways that could cover each part, so each pixel. And accordingly, once we have this information, indeed, one of the inputs that we can provide to the gateway in a future release, to the simulation in future release, is to tell the tool that I want at least 2 gateways to receive each device, for example, or 3 or 4 gateways. And the latter cases could be even required if you want to deploy some geolocation use cases, whereby you need triangulation in order to support TDOA or RSSI type of geolocating devices. So it's not yet the case, but that's something in our roadmap that we would like to have also in one of the future releases of the tool. This part I think I have already answered. If I work at a refinery, I think I have already answered this one also. How many brands of gateways do you support? So actually, on the network coverage tool, there is no specificity related to the gateway brand itself, as long as we support, so the gateways fulfill the original requirement, which is to be outdoor gateways and deployed at high points above the surrounding building's height or building rooftops. So any gateway could work. Whatever the gateway works with LRR or with basic station. So any brand of gateway can work as long as it's eligible. But if you want also to ask about what are the brand of gateways that are supported in ThinkPark Wireless or ThinkPark Enterprise or ThinkPark Community. So for that, we already have all the brands of gateways which are already documented online on our user guide. There is a question about credit. First credit package is 1,000 euros, but for how many credits? So this is a credit of 100, and it goes 1,000 euros. But afterwards, the credit per base station becomes digressive in price as you buy more credits. So the one for 1,000 euros is for a credit of 100 gateway simulations. Is the tool dashboard available in French? So for now, it's not yet geolocalized, so localized in different languages. But until this becomes available, I hope that you can rely on the translation of your browser. If you're using, for example, Google Chrome, it's generally easy to just activate the translation from Chrome. But since many of our almost all our other user interfaces are already localized, translated in different languages, so one day the network coverage tool will also follow the same thing. And the last questions are related to the presentation. So the presentation will be shared. It will be sent to everyone at the end. Does the tool consider building data? So no, because the tool already uses empirical propagation models that already account for the diffraction effect of the morphology, including buildings. So the tool doesn't use building or clutter data. It only relies on topography data, so digital elevation models, on top of the empirical propagation models in order to calculate diffraction. Because considering building data on top of the propagation models that we use would be too pessimistic and would account twice for the effect of diffraction on buildings. Do we provide a service to make the simulation? Yes, that would be possible, of course. One way of using the tool is to rely on credits. So you buy credits and you run everything on your own. But if you want Actility to do everything as a service, as a turnkey service, so of course that's possible. So we just encourage you to contact us offline so that we can find the suitable offer for your use case. So I hope we have already answered all the questions. Apologies if I have overlooked any question that was not intended at all, but I hope that we have brought satisfactory answers to most of them. And by that, I wish you all a good end of day or beginning of day, wherever you are. Thank you so much, and hope to meet you next time in another webinar. Goodbye for now.